What if a blockchain didn't just burn energy solving useless puzzles, but actually used all that power to train artificial intelligence? And what if that network's one massive goal was to build a decentralized artificial general intelligence? Well, that is exactly what Qubic is trying to do. So let's dive into this super ambitious and, yeah, pretty controversial project.
You know, we really have to start with a question that hangs over so much of the crypto world. When you hear about networks like Bitcoin using the same amount of energy as a small country just to secure themselves, a lot of people justifiably ask, couldn't all that computing power be doing something, well, more useful? It's that exact question that Qubic was built to answer.
And this slide right here perfectly lays out their solution. On the left, you've got your traditional proof of work. It secures the network by solving these abstract puzzles, and that's pretty much it. But on the right, you have Qubic's model, which they call useful proof of work. The energy still secures the network, but it also trains AI models. The huge difference is that the work itself produces something valuable, a genuinely useful byproduct.
So how does this whole thing actually work under the hood? Well, it's not your typical blockchain setup. Let's take a look at the pretty unique way Qubic comes to an agreement on things. At the very heart of the Qubic network is one very specific number. 676. That's it. The entire system is run by a fixed group of 676 special nodes they call computers. Just think of them as the dedicated backbone of the whole operation. They're responsible for everything from checking transactions to running smart contracts. You know, those automated agreements on the blockchain? And this fixed number is absolutely key to how the whole network functions.
So instead of having thousands of miners all competing against each other, like you see in Bitcoin, Qubic uses a system that's based on agreement, or a quorum. You can almost picture it like a high-stakes committee meeting. For anything to get approved, a big majority, a supermajority, has to vote yes. It's all about collaboration, not cutthroat competition.
And here's how that plays out. So, a transaction gets proposed to the network. Then, at least 2/3 of those 676 computers, that's 451 of them, have to agree that it's legit. Once they do, bam, the network updates. And get this, instead of waiting around for traditional blocks, which can take minutes, the Qubic network updates in what it calls ticks, and a tick happens every single second. So it's less like adding a new page to a book every 10 minutes, and a lot more like watching a live document that's being updated in real time. This means you get incredibly fast, almost instant finality for transactions.
You know, a project this ambitious doesn't just pop up out of nowhere. To really get what Qubic is about, you got to understand the person who created it and the seriously grand vision he's chasing.
The mind behind Qubic is Sergey Ivancheglo, but he's much better known by his online handle, Come From Beyond. Now, this guy is a legendary figure in crypto, maybe even an infamous one. He created NXT, which was a real pioneer in proof of stake, and he also co-founded IOTA. But his reputation also comes with a lot of controversy, which makes Qubic one of the most closely watched and, let's be honest, hotly debated projects in the entire space.
So what's the end game here? What's the whole point? It's this, Aigarth. The ultimate goal of Qubic isn't just to be another fast blockchain. It's to use its global, decentralized network of computers to build a true artificial general intelligence. So why decentralized? Well, the whole idea is to prevent any single corporation or government from controlling such a powerful technology. The goal is to make it a resource that's owned and governed by everyone. It is a total moonshot, to say the least.
Okay, but of course, a vision that huge is going to run into some serious challenges. Let's hit pause for a second, pull back, and take a realistic look at the hurdles and the other players trying to do similar things.
Qubic is definitely not alone in this quest to mix blockchain with useful computation. As you can see here, it's a crowded field. You've got projects like Render, which focuses on GPU rendering, BitTensor, which is creating a marketplace for AI models, and Akash, which is building a decentralized cloud. And while all of them are tackling decentralized computing in their own way, Qubic's explicit goal of building a single unified AGI is what really sets it apart. It just goes to show you how massive this trend is in crypto right now.
And the project is facing some pretty major hurdles. For one, the tech itself is incredibly complex. Then there's the huge question of whether it can actually scale and work the way it's supposed to in the real world, not just on paper. And on top of all that, the whole field of decentralized AI is brand new. It's highly experimental. I mean, we are in uncharted territory here, and there's absolutely no guarantee of success.
So, that brings us right back to the central question. When you stack up the massive potential against the very real risks, what are the possible outcomes for a project as wild as Qubic? You can really imagine 3 ways this could play out. The super optimistic future? Qubic actually does it and becomes a foundational platform for building decentralized AI. A more moderate outcome? It carves out a specific, really valuable niche for itself somewhere in the ecosystem. And then there's the pessimistic view. The technology just turns out to be too complex, way too ambitious, and it never gets off the ground.
And this quote just kind of nails it, right? Qubic is this fascinating mashup of really powerful ideas. You've got blockchain security, useful computation, and the bleeding edge of AI. It's one of the most experimental and ambitious projects out there, but its success is so far from guaranteed.
And that leaves us with the final question to chew on. Is this the start of a genuine revolution in how we build and control artificial intelligence? Or is it destined to be another fascinating but ultimately failed experiment in the wild world of crypto? I guess only time will tell.